Let's continue with the test review. This is part 2. We are talking about light rays. We just finished reflection. That was pretty easy. The angle of incidence equals the angle of reflection. And now we're going to look at refraction. So this is when your ray is going to enter your second medium. So it's incident on the second medium here from the first medium, but then it's actually going to go through. So as always, we always draw that normal so we can define our angles. So if the ray bends this way, this means that it's bending toward the normal, right? This is the normal line. The ray is not going in a straight line when it goes from one medium to another. It's not going in a straight line. It's bending this way, which is towards this normal line here. So when this happens, you know that you have gone from a low index to a high index. So N1 here and N2, and N1 is smaller than N2. When this happens, the speed also slows down. An abbreviation or a mnemonic here is FST here. This stands for fast, slow, towards. So if you're going from a fast medium to a slow medium, you're going to bend towards the medium, if that's helpful. And then the opposite happens if you're going from a high medium to a low medium, SFA. So from a slow medium to a fast medium, you're going to bend away from the normal. So if you have your ray is incident this way, and then it's bending away from the normal this way, then this means that N1 is greater than N2 because it's going from a slow medium to a fast medium, and instead of moving in a straight line, it bent that way, which is away from this normal line. We're always incident from N1 into N2, and that's going to help us define our angles as well. So the incident angle, theta 1, and then the refracted angle, theta 2. Same thing here. The incident angle, theta 1, and the refracted angle, theta 2. So once we can visualize this, we know these conceptual ideas about speed decreasing in a higher index and then speed increasing in a lower index. And then we can use Snell's law right here in order to find a missing value. Let's say we don't know one of the indices of refraction, or we don't know one of the angles. We've got 4 variables here. So if we have 3 out of those 4, then we can use Snell's law to find a missing one. So that's what this bullet here is talking about, that you can calculate either of the n values or the angle of the incidence or the angle of refraction using Snell's law. And then the other thing here is that you do have to be able to know your geometry, such as your alternate interior angles and corresponding angles. This is helpful when you have a problem such as a prism, where your ray is refracted through that prism, and so you need to use those angles to help you find the answer. We've done a few examples of those, but just to summarize the geometry skills that you should have. So you should know that these 3 angles here sum up to 180 for any triangle. And then you should know that if you draw a normal to a surface, then if your surface is tilted, so will the normal. That's your 90-degree angle. And then if you have an incident ray over here, and then let's say it's going to refract over here this way. So you should use your geometry to figure out the angle. So let's say that you know the angle of incidence here. Let's say you know the index of refraction here, and then let's say that you were going into some glass prism. Let's say that you were given N2. Well, the first thing that you could do is you could use Snell's law to find angle 2 right here. So using this equation, get theta 2 by itself. But then the geometry that you should know is, well, if you know this angle here, then you know that a right triangle is always 90. So if this is angle 2 over here, you should know that this angle here is 90 minus theta 2, because those two equal 90. And then you should be able to use that to figure out, well, if I know this is 90 minus theta 2 here, and if I know this angle, maybe that was given to me, then I can now find this angle, because all three of these angles must equal 180 degrees. And then the other thing that you should know is if you have those corresponding and alternate interior angles, so let's say you have a line going like this, you should know that these two angles are the same. And then if you have two parallel lines and a line cutting through them, then you should know that these angles here are the same. And that means that these angles here are also the same. And likewise, you should also know that these angles here are also the same. So all these three angles are the same.